Yesterday, we talked about parent functions. So we graphed y equals x and y equals x squared and square root of x and all of these graphs. Well, we're now going to do what we call transformations. We're going to change those parent functions so they're still linear or quadratic or cubic, but we're going to move them around, we're going to flip them upside down, maybe flip them horizontally, stretch them and pull them and do all of that. And transformations work the same way on all functions. So let's say you graph x squared and you use a specific transformation. And then you do the same transformation on y equals x. The change in the graph will be the same. So what we have here is a page that teaches us about transformations. Now these transformations come in pairs. So this says for questions 1 through 4, graph the functions y1 through y5 using the graphing calculator. Sketch what you see on the specified axis and describe the pattern. So, take up my trusty calculator. And you don't actually have to put them in y1 through y5. The first one is x squared. So I just graph x squared, and I already know what this looks like. So I draw the graph, and I label this as y1. Okay? Then I go back into y equals, and I graph y equals negative x squared. So, oops, negative x to the second. Oh, crap. And I graph it, and it looks like this. So that's y2. So these two go together, these two go together, and these two go together. But when you graph y5, hopefully by that time you've learned the pattern. So for y6, we don't actually have to graph it. You can just say, I know what the pattern is going to be, and then predict it. Does anybody remember how to graph absolute value? You go into math, and you go over to number, and it's the ABS. Yeah, number 1. Okay, so do this for all of number 1, and then we'll talk about the answers. I wouldn't quite move on to number 2 because there's a little bit of a trick to it. So I'll pause the video. Get started on that. For the second graph, you should have gotten this and that. And for the third graph, you should have got that. And have you picked up the pattern? What's the pattern? Reflect x-axis. So this is reflect x-axis. So you'll notice this is the transformation. Y equals the negative version of f of x. So that says if you take a function, I'm a weapon. Let me have that. So the reflect the x transformation is going to make it look like that. Now, so if you look at a function and you change all of the signs in the function, that will have the effect of reflecting the graph about the x-axis. Well, what if the graph looked like this? Well, when you reflected it, it would then look like this. So it just folds over the x-axis. Okay? Now, number 2 is a little bit tricky. Do you see a difference between f of x and f of negative x? Well, so the first one is outside, and the second one is inside. So notice parenthesis or absolute value of x and absolute value of negative x. So if I had x squared, Cody, if I had x squared and I wanted to do that, I would have to do like this. So this one is outside, and this one means put all of the x's in parentheses, and instead of parentheses x, put parentheses negative x. Okay? And you'll notice that as you go through the worksheet. I'm not going to tell you, but maybe. So look at number 3. Number 3 says you're going to add outside of the parentheses. So hang on, guys. Look up here, please. Jaron and Cambry. So when you get to number 3, see how it says x is in the parentheses and you add outside? When you flip the page over, this one. Now we take f of x, and instead of x, we write f of x plus or minus c. And that's adding inside. Adding outside and adding inside do two different things. Okay? So for each number, you need to figure out what that transformation does. So graph all of those, and I'll come around and help you out. But you'll notice that adding 2 inside does something different than adding 2 outside. So if I had x squared, and I wanted to add 2 on the inside, what would it look like? What's the difference if I wanted to add 2, and this one was outside, what would it look like? How do you add 2 to the outside of x squared? X squared plus 2. How do you add 2 to the inside? You put it in parentheses, and you write x plus 2, and then you square it. You will. That's where we're headed. So, but it's nice. It tells you exactly what it should look like. But notice how that happens on the inside. You just type in what's there, and notice that happens on the outside. I'm just highlighting that they do two different things. X squared plus 2 is different from x plus 2 squared. Okay? So all you have to do on this worksheet is graph all of the graphs, and then each number does basically the same thing. And you need to describe what that transformation is. So go through and graph all of the graphs on all of the functions. Number 2 does flip it across the y-axis, yes. Okay, go to work.